Okay, we are seeing that the last numerical on the corona discharge. Okay, so I think we up to the point calculation of critical disruptive voltage. Okay, have you solved that division with the help of a minus b whole square? Tell me, any one of you. By solving that with the help of that formula, have you got the answer same or different? Yes, please reply, anyone. Do that calculation first of all, because it is important. Okay, so a minus b whole square, a square minus 2ab plus b square. Okay, 64 square, 2 into 64 into vc square plus vc square. Okay, on divide 61.2 whole square minus 2 into 61.2 into vc plus vc square. Okay, 98 divided by 53 is equal to 64 square minus 2 into 64 into vc plus vc square. Okay, denominator 61.2 whole square minus 2 into 61.2 vc plus vc square. Okay, rearrange these two terms. Okay, 98 into denominator 61.2 whole square minus 2 into 61.2 vc plus vc square is equal to 53 into bracket 64 square 2 into 64 into vc plus vc square bracket close. Okay, now just multiply with 98 into the bracket. Okay, or first of all solve that bracket. Okay, afterwards multiply with 98 and 53. Okay, yes, any one of you got the answer? Yes, yes, do the calculation properly. Yes, am I audible to you? Yes, yes, am I audible? Yes, okay, I hope. Yes sir, okay. Simple, it is a mathematical calculation. Do it your own. Okay, and you will get the finally vc is equal to. Okay, one thing I want to tell you that over here such a type of question may be asked in your state government psu or central government psu. Okay, so they won't give you direct data, they will confuse you in such way that they will give you data in complicated way. Okay, they don't give you directly m0 g0 delta, they don't give you. Okay, they will give you like this data and they will ask you what is the critical disruptive voltage. Okay, so be remember that this type of numericals are very much important uh, competitive examination point of view. Okay, so it is very essential Be remember that how to calculate things. Okay, so one part we have determined or derived. Okay, Vc is equal to 54 kilovolt. Okay, now he has asked to calculate U at 113 kilovolt. What is the power loss due to the corona discharge? Okay, so okay, as I said earlier, all the terms are constant. For example, delta, frequency, radius, and small d. So the power loss is directly proportional to, into bracket, capital V minus capital V to the suffix small c, bracket close, whole square. Okay, use that same concept to calculate that uh, power power loss due to the corona discharge at 113 kilovolt. Okay, so that 113 kilovolt first of all converted into phase quantity. Okay, this is the line to line quantity, so that should be converted into phase quantity. Okay, so we will get W is equal to, let us consider W, it will be the power loss due to the corona discharge at 113 kilovolt. Okay, so put that value. Okay, Vc is known to us. Okay, so W is equal to, or W is proportional to 65.2 minus 54 whole square. Okay, so let it equation number 3. Okay, take the quotient of equation number 3 and equation number 1. Okay, or equation 3 is divided by equation number 1. You will get the directly value for the W. Okay, which will be 128 kilowatt. Okay, 128 kilowatt. Okay, this is the mathematical part. You should know this one, how to calculate that. Okay. So with this example, we will skip for the corona discharge. Okay, so in this corona discharge, we have seen that corona principle, terms, definition used for the corona discharge, empirical formula to calculate the corona discharge, and also we have seen that various important terms like critical disruptive voltage, visual critical voltage, okay, and factor affecting on the corona discharge also we have studied. Okay, and also we have studied that advantages and disadvantages of the corona discharge, and lastly we have seen that methods to improve the corona discharge or corona effect. Okay, I think that this one is the 70% to 80% part of that first unit we have successfully completed. Okay, we have till 5 minutes for the today's lecture. Okay, we will just take the introduction regarding sag in overhead transmission line. Okay, am I audible to you properly? Yes.
Yes, sir.
Okay, so we will introduce a new terms in electrical power system. That is what the sag in transmission line. Okay, so all of you seen that some slack in overhead transmission line conductors. It is on both side, means what, in a distribution side as well as in transmission side. Okay, I think आपण सगळ्यांनी हा पाहिलेला आहे सॅग ओव्हरहेड ट्रान्समिशन लाईन. आपण दोन टावर मध्ये पाहतो ना, कंडक्टर कसे असे जोड पडल्यासारखे असतात, तर ते का असतात आणि ते किती ठेवावे लागतात ते आपण डिटरमाइन करणार आहोत. बिकॉज ऑफ इट विल अफेक्ट्स ऑन दॅट life of transmission line or we can say that it will helpful to reduce the maintenance cost also. Okay, how it will be, we will see that. Okay, so first of all, we will see what is meant by the sag in transmission line. Okay, it is observed in both case, distribution as well as transmission side. Okay, so in a transmission line, sag is defined as the vertical difference in level between the points of support, most commonly transmission towers, and the lowest point of the conductors. This one is the simple definition for that sag in overhead transmission line. So once again, I will repeat in Marathi. Sag is nothing but what? की बघा, सॅग म्हणजे काय असतो की लोअर मोस्ट पॉइंट ऑफ कंडक्टर. आता दोन टॉवर मध्ये जे कंडक्टर्स असतात ते असं जोड पडल्यासारखे दिसतात. तर आपण जर लोअर मोस्ट पॉइंट पाहिला कंडक्टरचा आणि टॉवरचा टॉप, या दोघांमध्ये जे काही व्हर्टिकल डिफरन्स आपल्याला दिसून येईल तो काय असतो? शाग म्हणतो आपण त्याला, शाग. ठीक आहे. शाग इट इज आय थिंक व्हेरी popular or familiar concept in electrical power system. Okay, our state government PSU, for example MSCB, Transco, Disco, definitely they will ask you one question on the sag. Okay, so be remember that the concept of sag, how it will be calculated, and on what parameter it will be depends. Okay, so once again I will read that sentence. Definition for the sag. Sag is nothing but a vertical difference in level between the points of supports, mainly transmission towers, and the lowest point on the conductors. Okay, the calculation of the sag and the tension in the transmission line depends on the span of the overhead line conductors. Okay, this one is what just introduction for the sag. Okay, so have you clear the idea, or we can say that sag? Have you got the idea?
Yes, sir.
Okay, so see over here in the diagram, this S represents that vertical distance. Okay, this A and B, we can say that at point A and at point B, two towers are there. Okay, at point A one tower is there, at point B another tower is there. Okay, between these two towers our live conductors are suspended, or we can say that fixed at a cross arm. Okay, so some slack is observed in the line conductors. Okay, so this O it is the lowest point, okay, on the line conductor. Okay, so if we it's a projection, if we draw horizontally, and we will measure the vertical distance from the top of the tower. Okay, top of the tower, especially from the cross arm, we will see that. Okay, आपण हे वर्टिकल डिस्टन्स कुठपासून मेजर करणार आहोत? आपण स्ट्रिंग इफिशियन्सी मध्ये पाहिलं बघा की सस्पेन्शन इन्सुलेटरचं जे टॉप असतं ना, जिथे की आपण गार्ड रिंग वगैरे लावतो, तिथून या लोएस्ट पॉइंट पर्यंत आपल्याला वर्टिकल डिस्टन्स मेजर करायचं आहे. तर तुम्ही म्हणाल की सर सॅग हा आय थिंक जनरली दोन टावरच्या मिडल मध्ये दिसून येईल. ठीक आहे, लोएस्ट पॉइंट. मग तिथपर्यंत कसं आपण ते डिस्टन्स मेजर करू? तर एक इमॅजिनरी लाईन ड्रॉ करून आपल्याला काय करायचंय, वर्टिकल डिस्टन्स मेजर करायचे क्रॉस आर्म पासून. ठीक आहे, म्हणजे जिथे की आपले लाईव्ह कंडक्टर्स हे सस्पेंड केलेले असतात, ठीक आहे, किंवा फिक्स केलेले असतात, त्याच्यामधलं वर्टिकल डिस्टन्स आपल्याला मेजर करायचं आहे. आता हे कसं मेजर करतात? बाय युजिंग द लेवलिंग अँड सर्वेइंग टेलिस्कोप. सिव्हिल इंजिनियर करतात बघा रोड वगैरे बनवताना, की टेलिस्कोप यूज करून ते सरफेस वगैरे चेक करतात की किती प्लेन आहे किंवा किती रिजेस आणि ग्रूव्ज आहेत वगैरे. ठीक आहे, त्या टेलिस्कोपचा यूज करून आपण हे हॉरिझॉन्टल इमॅजिनरी लाईन ड्रॉ करून वर्टिकल डिस्टन्स मेजर करणार आहोत. ठीक आहे, जनरली this sag in the transmission line depends upon the span of overhead conductors. Okay, especially span of the or span between the two towers. Okay, दोन टावरच्या span वरती depend असतो. Okay, so for today's class this is enough. Okay, almost time is over. Okay, I will fastly take the attendance. Okay, roll number 1, 2, 3 is absent. Please don't leave the meeting because I have not taken attendance. Roll number 6, 7, 8, 9. 9 is present. 10, 11, 12, 13, 14, 17, 18, 19 is absent. Yes, please mute yourself. Who is that? 22, 23, 24. 24 is absent. Roll number 24. 26 is absent. 28, 29, 30, 31, 32, 33, 34, 39, 41, 42, 43, 44, 46, 47, 48, 50, 51. Okay, you may left the meeting. Okay, so today we will stop over here.